Okay, in this example, I'm again going to be solving a system of equations. I'm going to be using the method of elimination. And as I look at these two equations, I notice right away that the first equation, that all three terms are divisible by 2. In the second equation, 6, 15, 21, all three of these are divisible by 3. So sometimes it's a good idea to even multiply by a fraction. So I think what I'm going to do in this case is I'm going to multiply equation 1 by 1/2, and I'm going to multiply equation 2 by the number 1/3. And simplifying is always a good idea. Let's see what this does to the problem. So multiplying equation 1 by 1/2, 1/2 of 4 is 2, 1/2 of 10 is 5, and 1/2 of 14 is 7. Likewise, multiplying equation 2 by 1/3, 1/3 of negative 6 is negative 2, 1/3 of negative 15 is negative 5x2, and 1/3 of negative 21 is negative 7. Now, right away now that I've simplified the two equations, it's pretty clear that all I have to do is add these two equations together, and I will eliminate the x1s. Incidentally, this is a case where if I add the two equations, I'll also at the same time be eliminating the second variable, and unlike the last example, we will also be canceling the right hand side of the equations. So that means that since 2 plus negative 2 is 0, I end up with 0 x1. Since 5 plus negative 5 equals x2, I get 0 x2. And 7 plus negative 7 is 0. And of course, 0 does indeed equal 0. A moment ago we saw an example where we got to this point. We got a contradiction, and so therefore we said the system was inconsistent. In this case, we arrive with a tautology, which is true. In this case, we'd say that there are infinitely many solutions. And we would also say that the system of equations is consistent. Now, a moment ago, we saw an example of a system of equations that had exactly one solution. In that case, I would also say that it's consistent. But it's possible to have a consistent system of equations that has only one solution. It's possible to have a consistent system of equations that has infinitely many solutions. So consistent simply means that there's at least one solution. Inconsistent means that there is no solutions.